Hi, let me welcome you to this screencast. In this session, we'll be looking at a practical introduction to unit testing in JavaScript using QUnit. I presume you're watching this video because you realize the need to test your application. And as a developer, any sort of testing which leads to a better product is highly recommended. We know the ultimate sort of testing happens to be the one from the user perspective. That's the user acceptance test. But then, as a developer on your own, you should be able to carry out unit testing and other related sort of testing on your application to be very sure that your code conforms to the requirements given to you. Now, so you probably would like to find out why would you want to test in the first place. Once again, I assume you know those reasons, but if you don't, I've highlighted them here. So some reasons for testing softwares. Probably, if you're like most developers, and I am, we are not perfect. So the codes we develop may have faults in them. We need to find or use a logical means of detecting such flaws in our codes. And testing, I must emphasize that a proper testing should lead you to find such failures in your code. And once such failures are identified, and then you provide remedies for them, or you restructure your code or correct those anomalies, then the quality of code you churn out will be very, very high, which happens to be the second point. And then once the quality of code is very high, it gives you, the developer, the confidence to know that the products you are delivering to your clients are of the highest quality, and then you can have your peace of mind when you go home. So basically, what do you need in order for you to test your application? And obviously, as you would have guessed, you need your application, that's your codes, your source codes, and then a testing framework. Basically, a testing framework provides a means for you to test unexpected results against an actual, right? Because that's even the whole thing about testing. You should know you should know the expected results, and then based on the actuals we get from a certain function call or wherever the data will be coming from, you just compare it to the expected results. A typical example would be having a mathematical function which sums up two numbers, right? If you pass it 2 and 3, you always expect the results to be 5. So in such a scenario, the testing framework will provide you a means for you to invoke the function and then test it against your expected results, which should be like 5 in the contrived example I just cited. Let's now look at some testing frameworks around. Okay, so I guess you really want to get your hands dirty by coding. Let me quickly do that. Since we'll be using QUnit, let's just head over to jquery.org. And yeah, there's our QUnit, so you can just pick it up. So from here you can read all about QUnit, but we are interested in picking the codes itself. And as you can see, they have some examples here, code examples you can go through. But we are interested in working with it, so scroll somewhere down and then look for the GitHub link. Yeah, once you are here, you see the download link. Just click on that to pick the source code. I've already downloaded it, so I'm not going to pick it up. You can get the tar.gz file. Once QUnit is downloaded, so this is why I placed my download in my directory blog. Let's just extract that. Okay, so we can, and once you have it extracted, okay, the only things we need from this for our application to work only happens to be the QUnit folder itself. But then let's pick the QUnit and then the test folder. Let's set up a new directory here, and let's call it unit testing, and just drop this. Let's open the test. Okay, so we can get rid of this, the header, headless, logs, and get rid of those files. Okay, so these are directory structure. Blog. Okay, so as you can see, this is just a directory structure. We need the QUnit itself, and then we have the test folder with this content. So let's get to work. We are now going to develop a mass utility library with common functionalities such as summation of numbers, subtraction, addition. Sorry, that's addition. I mean, addition is summation, multiplication, and a host of others. But because of time, we'll just do the summation. It should fairly let you know what testing is all about. So quickly, let's create our file. Let's call it math.js. It's a JavaScript file, and we said it should be able to do the summation. So we are going to define the summation function. Let's say function sum, and it should be able to sum up any number. So we are not going to put any parameters here, right? Let's declare sum total. At the moment we are going to return the whatever we have in the total. Right. Num, we'll set it to 0. Each of the numbers we iterate will be assigned to the num variable, and let's say num of arguments is argument dot length. It should be a pretty simple function. So for yeah, okay, so our function is done. I must say, so as you can see, the name, it sums up numbers. Any number of numbers you pass to it will probably do it for you. A typical invocation would be sum 1 2 3, right? Sum -2 5. So it can take any number of arguments, right? Once our function is done, now, as you can see, we maintain this folder, right? But we just got rid of some of the files in it. Open the index file. Okay, so here the only thing you need in your HTML file happens to be the CSS file and then the JavaScript file itself. That's the QUnit JavaScript file. All this. Okay, we are going to maintain the test file. We'll put our test in it, and then what's the file we are testing for, we need to have it here, math.js. You could probably change this. Okay, now that everything is set, let's quickly open our test folder, right? Let's get rid of everything and let's be sure everything is working. So let's try and view this file. As you can see, this is what you get. It's based on the settings we had over here. QUnit header, you can easily change it later on. Okay, let's do that. So as you can see, it has been changed, and because we have no test in there, so no test was actually run. So let's quickly test our little function. In order for you to test in QUnit, you just use the test, invoke the test function, and then here you are supposed to give it a test name. Let's put something, just something there, so you know what it stands for. You pass it a function, and then you start your test. Now, because this is a mathematical function, we are interested in finding out the value that was returned. So you use the equal okay, and here you can provide an optional string which will be displayed. You see its purpose very soon. Now this is what happens. We are telling the testing framework that anytime we invoke a function, this function, the sum function, and we pass it 2 and 3, we always expect the results to be equal to 5. Alright, so let's run it and see what happens. Okay, you realize the name we give to this particular test, we didn't really give it any appropriate name, so we can go back and then change it. And in other frameworks, this will probably refer to the name of the test itself, or the test method that needs to be run. But here, once it's JavaScript, you can give it anything you want, but let's stick to that same convention. So we say test sum with valid arguments. Once we run this, it says 1 test of 1 passed, 0 failed. So it means our function is working as it should. Once you can drill down by clicking on it, and you see this string that has been displayed is actually this value that you place there, right? It's an optional string, you can decide to leave it, and it says the expected value happens to be 5, and actually that's what we got. And then the beauty of testing is, are we sure this function actually works with negative numbers and all that? So we can actually do 2, 3. So 2, 3, let's say 5. We expect the result to be 10. So we can optionally change this. Let's add 5 to it, and we say 10. And then what happens if you pass the -6, and then negative 6 and 5? We expect the results to be -1. Right. Like I said, this part is optional, you can actually leave it. Let's run the test again and find out. So as you can see, if you leave the optional text at the end, it puts okay. It means everything was perfectly run as you expected it to. So this is what we have. Now, like I always keep on saying, a test, once you have this test, then you can always run it by just hitting the URL to this particular file, right? Let's say someone accidentally makes a change within our code. So instead of starting from 0, it starts from 1. Immediately we run this, you get to see all of these errors, because instead of running through all the items, it starts from the second one and runs to the end, which will probably give us the wrong results, as we are noticing here. So this is a pretty cool way. If your code ever gets broken or something like that, you can just run the test and then you get the expected results without manually going to do it. Now let's quickly go back and then put the right thing over there. Once we refresh, realize we get our test as it should be. But then one interesting thing you need to know that a test should always lead to the discovery of, let's say, errors in your codes, right? Let's start with a new test. Let's say test with invalid argument. Now, how is our code going to behave if you pass it a number and then something which is really not a number, right? So let's get rid of all of this and let's see what happens. Ouch. So as you can see, your code, the code that we just developed, right, is not handling non-numeric values very well, and we need to fix this. We need to fix this. This is now the modified version of the code we have, the sum function. Our new additions, we are now throwing an exception if no argument is passed to our function, right? And then here, if you look at the part that will actually do the summation, we're also checking to make sure that the argument we have is actually a numeric value which can be used in a computation or in a summation operation, right? Now quickly let's go back and then test if this works. Oops, we refresh and we are getting this particular error. Died on test number 1, only numbers are allowed, but found, it cannot determine the type of this. It's supposed to be a string. Now this is what you have. You realize anytime you invoke that particular function, it throws an exception. So what it means is, in our test, we should be testing for an error which is being thrown. That anytime we pass it a numeric value and something which is non-numeric, an exception is always thrown. We cannot easily test for that. So as you can see, this is the updated test we have. We still have testing with valid arguments. I've added a couple of test cases to it. And apart from equal, you can also say not equal. We expect that when you pass it 2 and 1, we know the result should be 3. So we say it will never be equal to 5. We're just showing you how to use the not equal. And then we have a second test which says test sum with no arguments. And based on a definition of sum, we says once we are not getting any argument, we should throw an exception. So in this case, we are just throwing an error, basically the same concept. And then if we have something which is non-numeric, we should also throw an exception. So we have those tests here. Call sum with no arguments, call it with data that will result in an exception being thrown, and then we have all of this. Let's try and then run our test and make sure that our code passes. Yes, and lucky for us, all our test scenarios work perfectly. We have all of these test cases being run successfully, and then when it comes to arguments, call test with no arguments, it says an exception is thrown, which is perfect. That's what we expected. And then call it with data, which results in an exception. And then here it's telling you if you pass it a string, it will be rejected. If you pass it an object, it will also be rejected based on the optional string we provided at the end. So it gives you an idea of what test you were running. So that's basically it for unit testing. I hope it was really helpful. You could head to my blog. So you could head to my blog where I have this. I have the same stuff over here. Everything written with the codes ready for you to download. Everything is ready. With an even extensive example which goes beyond just dealing with mathematical functions. It looks at dealing with models in JavaScript and all that. As you can see, this is the UML diagram for it, the codes, and then what you are testing for. Everything is available on the site. Everything is available on the site with an option for you to download it if you're interested, if the source code provided. So thank you for viewing this video.